بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some additional exercises about section 1.1. The first question, this is a function f of x and this is a function g of u. Is it true that f equals g? And the answer is yes. F equals g. Because if you want to find f of any number, it would be equal to g of that number. So for example, f of 1 would be 1 plus 2 square root of 2 minus 1. G of 1 would be also 1 plus 2 minus square root of 2 minus 1. So whether you write it f of x or f of t or g of u, since it has the same definition, so it will give you the same answer, and f equals g. The same question here. This is a function f and this is a function g. And is it true that f equals g? Of course, the two functions are different, but if you factor the numerator here, if you take x as a common factor and divide by x minus 1, you notice that you can cancel x minus 1 with x minus 1 and you get x. So the question remains, is f equals g? Well, now they are the same. F of x is x, g of x is x, but f of x wasn't x from the beginning. It is x squared minus x over x minus 1. So if we find the domain of f, it would be all real numbers except 1, because 1 makes the denominator 0. So the domain of f would be from negative infinity to 1, union 1 to infinity. This means f of 1 is not defined. F of 1 is not defined because 1 is not in the domain of f, while g has domain or real numbers. So there is a difference between the domain of f and the domain of g. So f is not equal to g at 1. So f is not equal to g in general because they are different in one value. F of 1 is not defined while g of 1 is 1. Because of that, f is not equal to g. Because when you say f equals to g, it means they are always equal. So here they are always equal. You will never find a number in which f and g are different. These are two graphs. The red one is the graph of f, and the blue one is the graph of g. So state the values of f of negative 4. F of negative 4, 1, 2, 3. This is negative 4. Now f is the red one, so I go down, so it's negative 2. So f of negative 4 is negative 2. While g of 3, x is 3, so 1, 2, 3, this is 3. G is the blue one, you go up, 1, 2, 3, 4. So this is 4. So g of 3 is 4. Which is larger, f of negative 3 or g of negative 3? Well, x is negative 3, so negative 1, this is negative 3. Now, g is the blue, so g of negative 3 is above f of negative 3. G of negative 3 is positive. F of negative 3 is negative. So in fact, g of negative 3 is greater than f of negative 3. It's larger than. For what values of x is f of x equals g of x? F of x is the red one. G of x is the blue one. They are equal here at this point and at this point. They are equal here. So for what values of x? Here x is negative 2. So at x equals negative 2. Also here they are equal. And here x is 2. So f of x is equal to g of x at x equals to -2 and x equals to 2. On what intervals is f of x less than or equal to g of x? Well, f less than g, f is the red one, it is below g, g is the blue one. So in this part, g is greater than f. So from negative 1, 2, 3, 4, from -4 to -2, from -4 to -2, f of x is less than g of x or equal. Also, f, which is the red one, is less than g from 2 to 3. Okay, 2, 3, because g is not defined after 3. Okay, so we say only from 2 to 3, f is less than g. So union 2 to 3. State the solution of this equation. F of x equals -1. F of x equals to -1, it is this line. This is the line, y equals -1. It intersects the graph of f at this point and at this point. So the question is the solutions. So the solution would be x is -3 and x is 4. So the solution, x is -3 and x is 4. When x is -3, f of x would be -1. And when x is 4, f of x would be -1. On what intervals is g decreasing? G is the blue. It is decreasing here from -4 to 0. So it's decreasing on the interval from -4 to 0. State the domain and the range of f. The domain of f is the red one. So the domain, all the possible x values from -4 to 4. So the domain of f is from -4 to 4. The range of f, the range all possible values of y. So here -2, and here the highest point is 3. So from -2 to 3, that's the domain of f. State the domain and the range of g. G is the blue one. The domain is from -4 to 3. So the domain of g from -4 to 3, and the range of g, this is the lowest value, the lowest y value. Say it's about 0.5 and up to 4. So from 0.5 to 4, that's the range of g. Evaluate the difference quotient. So f of a plus h would be a plus h to the power 3 minus f of a is a to the power 3 over h. If you have a plus h to the power 3, this is equal to a cube plus 3a square h plus 3ah square plus h cube. This is a formula how to find the cube of a binomial. Minus a cube over h. A cube is cancelled with a cube, and you can take h as a common factor from these terms. So you will have 3a square plus 3ah. Here h square, you take one of them as a common factor, plus h square. You have h cube, you take one of them as a common factor. So you can cancel h with h, and the final answer would be 3a square plus 3ah plus h square. Here, f of x is 1 over x. F of a is 1 over a over x minus a. I will write it 1 over x minus a. The denominator, I will take it out, times 1 over x minus 1 over a. This is important to simplify the figure. So 1 over x minus a. And now I need to add or subtract these two fractions. For the formula, you multiply a times x, the two denominators, and then you multiply a times 1, which is a, minus 1 times x, which is x. So this is how we subtract two fractions. Now you have a minus x here and x minus a here. You can cancel these two with a difference of -1, because the difference between x minus a and a minus x is a -1. So 3 over -3 is -1. So the answer would be -1 over ax. Here f of x is square root of x plus 2. F of 1 is square root of 1 plus 2, which is 3, over x minus 1. There is no way to simplify this one unless you multiply by the conjugate of the numerator, which is square root of x plus 2 plus square root of 3 over square root of x plus 2 plus square root of 3. So this is 1. Anything over itself is 1. I am multiplying it by 1, so I did not change anything. Now, how to multiply two fractions? You multiply the numerator times the numerator. And if you multiply a minus b times a plus b, you get a square minus b square. So when you square this term, you get x plus 2. And when you square this term, you get 3. And you multiply the two denominators. Now x plus 2 minus 3 is x minus 1. You can cancel x minus 1 with x minus 1, and the final answer would be 1 over square root of x plus 2 plus square root of 3. Find the domain of each function. The denominator cannot be 0. So this equation, I have to find the 0 of this equation and remove it from the domain. To solve this equation, I take 1 to the other side and then cross product. Okay, this is -1 over 1. So negative u minus 1 equals 1. Take 1 to the other side. So negative u equals 2. So u is negative 2. Okay. So u cannot be negative 2 because if u is negative 2, then this denominator would be 0. If you replace u here by negative 2, you have negative 2 plus 1, negative 1, 1 over negative 1, negative 1, 1 minus 1 is 0. And also u cannot be equal to negative 1 because this denominator cannot be 0. So the domain of f consists of all real numbers except negative 2 and negative 1. If you want to write it in interval notation, you say from negative infinity to negative 2, union from negative 2 to negative 1, union from negative 1 to infinity. Here I have two square roots. 2 minus square root of b cannot be negative because then the square root is not a real number. So it has to be greater than or equal to 0, which means that negative square root of b should be greater than or equal to negative 2, or if you multiply by a minus sign, then square root of b should be greater than or equal to 2, which means if you square both sides, because both are positive, so you can square both sides here. So b should be less than or equal to 4. But also b is inside the square root, so it has to be greater than or equal to 0. So p has to be less than or equal to 4 and greater than or equal to 0. So the domain of f is from 0 to 4. If you choose any other number, for example 5, then 2 minus square root of 5 is negative, and you cannot find the square root of a negative number. Here I have a square root, so x squared minus 4x minus 5 should be greater than or equal to 0. If you factor this trinomial, x squared, you can write it x times x, and you search for two numbers, their product is negative 5, their sum is negative 4. So negative 5 and plus 1. Negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. Now the zeros of these two terms, I have negative 1 is a 0 and 5 is also a 0. I need the product of these two should be greater than 0. If you take a number between negative 1 and 5, say 0 for example, if you replace x by 0 here, then you have negative 5 and 0 plus 1 is 1. If you multiply negative 5 times 1, you get negative 5, which is not greater than 0. So in this interval, the product is not greater than 0. So in these two intervals, the product would be greater than 0. So if you replace 5 by 6, 6 minus 5 is positive, 6 plus 1 is positive, and the product is positive. And if you replace x by negative 2, for example, negative 2, negative 5 is negative, negative 2 plus 1 is negative, negative times negative is positive. So in these two intervals, the product is positive. So the domain of h would be from negative infinity to negative 1, union from 5 to infinity. And because the equality is there, so the intervals are closed. Find the domain and the range and sketch the graph of this function. Well, if you write h of x, y, and you square both sides, and then if you take x squared to the other side, then you have this equation. And this equation is an equation of a circle with center at 0, 0, and radius is 4, 2. Radius would be square root of 4, which is 2. So you can graph the circle. But the function is not the circle. The function is y equals square root of 4 minus x squared. Y equals to positive square root. So y is positive. So in fact, the graph of this function is the upper half of the circle. So the graph of this function, h of x, is this figure, the upper half of the circle. So from here, I can determine the domain of h. It's from 2 to 2, the domain, while the range of h is from 0 to 2. Find the domain and sketch the graph of this function. You can factor x squared minus 4 to x minus 2 times x plus 2. And you can cancel x minus 2 with x minus 2, and you have only x plus 2. So the graph of this function is the graph of this line, y equals x plus 2. If x is 0, y is 2. If y is 0, x is negative 2. And that's the graph of this line, which is the graph of this function. But there is a difference between this function and this line. This function is not defined at x equals to 2, because when x2 is 2, the denominator would be 0. So if x is 2, I go up and make an open circle here. Okay, so this circle is open. So the graph of this function is the same as the graph of this line everywhere, except when x is 2, it is not defined. And that's why these two functions are not equal, are not the same, because they are different when x is 2. Sketch the graph of this function. I have an absolute value. So absolute value of x is either x when x is positive, or it is negative x when x is negative. So either the graph is 2x, x plus x is 2x when x is positive, or x minus x is 0 when x is negative. So this is a piecewise function, and 0 is the important number. To the right of 0, I have a function, straight line. To the left of 0, I have also a straight line, which is y equals to 0. Y equals to 0 is this line. Okay. And it doesn't have the 0, so it's open here. Y equals to 2x is a straight line. To graph the straight line, I need 2 points. I'll start with the 0. At 0, if x is 0, y is 0. If x is 1, y is 2. So this line. So the graph would be this. This circle was open when we considered y equals to 0, but it is now closed because the two functions are equal at 0. So this graph is continuous, okay? What about this function? This is an absolute value, so it has two definitions. Either it is 1 minus 3t if 1 minus 3t is positive, or it is negative 1 plus 3t if 1 minus 3t is negative. If you solve this inequality, you will have negative 3t greater than or equal to negative 1, or 3t is less than 1, or t is less than or equal to 1 over 3. So I can write this again, 1 minus 3t if t is less than or equal to 1 over 3, or it is negative 1 plus 3t if t is greater than 1 over 3. Now to graph this function, it's a piecewise function, and the important number here is this number, which is 1 over 3. To the right of 1 over 3, the graph is negative 1 plus 3t, and to the left, y is 1 minus 3t. So to the left of 1 over 3, I will sketch the graph of this line. I will start with 1 equals to 3, the number, the important number. If you replace t by 1 over 3, negative 3 times 1 over 3 is negative 1, 1 minus 1 is 0. Also here for this line, if you replace t by 1 over 3, you get negative 1 plus 1, which is again 0. So 0 is common. But here, to graph this one in this area, I'll choose t to be 1. So negative 1 plus 3 is 2. So if this is 1 over 3 and this is 1, at 1 it is 2. So this is this part. And here, if I choose negative 1, okay, or I can choose negative 2 over 3. If I choose negative 2 over 3, negative 3 times negative 2 over 3 would be negative positive 2. So 1 plus 2 is, let me check, negative 3 times negative 2 over 3. Yeah, it would be 2. So 1 plus 2 is 3. I need negative 1 over 3. So I'll choose negative 1 over 3. Of course, you can use negative 2 over 3. You can use negative 1, anything. But I'm choosing negative 1 over 3 because if you replace t by negative 1 over 3, then it would give you 1. 1 plus 1 is 2. And here you have also 2. So you can sketch the graph. So this is the graph of this function, absolute value of 1 minus 3t. Here I have again absolute value. So either it is x, so x over x, or it is negative x. It would be x over x if x is positive. It would be negative x over x if x is negative. So it would be 1 if x is positive, and it would be negative 1 if x is negative. So this is a piecewise function. To the right of 0, y equals 1. To the left of 0, y equals negative 1. And this point is not included because the equality sign is with the right part. So this is the graph of this function. Find a formula for the function whose graph is the given curve, the bottom half of the parabola. The graph of this equation is a parabola. If you solve this equation for y, then y minus 1 would be plus or minus square root of negative x, or y is equal to, if you take 1 to the other side, plus or minus square root of negative x. This means that negative x should be positive because it's inside the square root, so x should be negative. Now this is a graph. These are two graphs. The bottom half of the parabola, in the bottom half of the parabola, y should be negative. So y would be negative bottom half if you choose the negative sign. Okay, notice here negative x is positive, so x is negative, less than 0. Okay, so this would give you the bottom half of the parabola. The top half of the circle. If you solve this equation for y, y minus 2 would be plus or minus square root of 4 minus x squared. If you take 2 to the other side, then this is again the same equation, but it has plus or minus. The top half would be the one with the positive sign. So this equation would be the equation of the top half. The equation of the bottom half would be 2 minus square root of 4 minus x squared. That's the last question. Thank you very much and see you in another